Okay, so here we have AOKFLY's RV2306-2400KV motor, R Vector Fire Phonetics. So I'm sure they meant Phoenix. So I had seen this one over at Banggood, and I thought it was kind of interesting. So I kept just kind of forgetting to order it. So finally I ordered it, and it finally arrived. It's been out for a while now, so a lot of people have tested it, and there's quite a lot of comments on the product page on Banggood. Some people have had issues, some people like it. So typical of a budget motor where it's kind of hit and miss. Some people have had a really good experience, others have not, as that's the case for most budget motors. So it comes in this box, and they only give you the lock nut, nylock, and 4 M3x5, I believe, screws. So the motor is pretty interesting, actually kind of good looking. I like the color, puke green, and it's kind of a matte finish. So let's see what it weighs. This is with they give you 140 millimeters worth of wire, which is it's long enough for 4-in-1 ESC in the center plate of the frame. So that's a good length. So with all that wire, the motor weighs in at 34.7 grams. So if we cut the wires to about 50 millimeters, we'll be getting rid of this much wire. So we would get rid of about 2 grams of wire. So it's about 32.7 with 50 millimeters worth of wire. So the motor is about 32.7. Not the lightest motor. Most of the motors these days are weighing in at of this size are weighing in at about 30 grams. Of course, they're using the naked bottom style, and also, you know, this being a budget motor, I'm sure they're not optimizing the weight. But 32 grams, not too bad. It's a okay weight. It does have this shaft retaining screw, which actually was kind of loose. It didn't take that much effort to get it loose, and then I noticed they don't use thread lock. So if you get this motor, I'd really recommend that you check the shaft retaining screws, remove it, and check if they've used thread lock. If they haven't, then make sure you put a little dab of thread lock. The one to use is the purple one, because that one is the one that has the least strength, so it's easy to remove. You won't mess up the screw if you're trying to remove, if you use the stronger one. The bell assembly was pretty hard to remove. It was stuck pretty well on the bearings. People sometimes ask me how to remove the bell assembly on some motors that are difficult to remove. So there's several different methods that you can use. For this one, it was kind of made it easy that it has a shaft retaining screw. So what you do is you loosen the screw just a little bit. Make sure there's a gap right there. So you loosen the screw, and then use another screw on the motor base. Make sure it's threaded in all the way, but make sure you don't hit the windings. So make sure it's threaded all the way, because you don't wanna mess up the threads right there. So you're gonna use, and the best ones to use are ones that have a sort of a large head. So then you'll need a set of pliers, needle nose pliers. The ones that are bent work best, but you can also use the straight ones. You can use the small ones too. So what you want to do is you want to grab the screw from the head. Make sure the head, the pliers go between the motor and the head of the screw, and the tip of your pliers rests on the retaining screw on the shaft. Also, it's a good idea to put in a prop. Best one is the a two blade prop, so you can easily grab the motor. So that gives you better place to grab the motor with a two blade prop. So then you use the needle nose plier as a lever, so you pull on the plier away from the motor like so. So what that's gonna do is gonna push the see, it's gonna push the bell out, and it's gonna loosen it. So if it's stuck due to friction or rust or whatever, sometimes there's a thread lock that might have spilled on there. This will help you get it loose. It might not work all the time, but it works most of the time. So once you do that, it's gonna push it out, and after that you can remove the retaining screw, and it should come off easily. So that's one way to do it. There's other ways to do them too, but that I found that to be the easiest. When they don't use screw, it gets a little bit harder. Then you have to use another screw and just kind of just rest it on the shaft like so, and with the needle nose pliers you grab it, and then you use that to push on the shaft like that. But you have to be careful not to damage the bearing. So you're just gonna push on the shaft just to get it loose. So that works sometimes it doesn't. So okay, now that the bell is out, let's have a closer look on the magnifying glass. Here's the bell assembly with the magnets on the magnifying glass. As you can see, they're using a 3mm shaft. Not much information on the company's website, AOKFLY. It's kind of doesn't work. There's no specs on the motor. So I don't know what kind of magnets these are. I don't know what kind of aluminum they're using. Most likely 6061 aluminum. I don't think they're using the fancy 7075 aluminum. And magnets, not sure if they're N52 or what kind of magnets they are. They are curved, so that's pretty good for a budget motor. But and you can see there's some balancing epoxy there, so it looks like they've done dynamic balancing of the bell. One thing I do notice is the magnets are pretty much on the edge of the bell, so they haven't used epoxy around the magnets, so very little adhesive for the magnets, not a lot of epoxy there. So hopefully that's not an issue, you know, where the magnets are gonna get loose when the motor is highly loaded. So hopefully that's not an issue. So the bearings, as you can see, they're 3x8x3, and the stator is the nominal 6mm, so no surprises there on the stator. The laminations, they seem to be 0.2mm laminations, which is typical for most motors these days. Windings are pretty neat, actually, not too bad, but I did notice a problem with the windings. This particular one, this wire, wasn't wound tight, so it was actually sticking out more than the others, this one wire, so it was bulging out a lot. So I don't know if you can see on the video, but there's a little shiny spot there. That's where it was rubbing against the top of the bell here, and I don't know if you can see it, but there's the mark right there all around. a little shiny line right there. That's where it was rubbing. I didn't hear anything, I didn't notice anything until I opened it. I noticed that that wire was worn out, so that was from rubbing. So QC a little bit not what you would expect, what you would want. Now that's typical of these budget motors, I guess. That's why they're so cheap, because they just make them as fast as they can and spend as little time inspecting them. So you know, it's always good to inspect them on your own when you receive them. Make sure the shaft retaining screw is tight. If it doesn't have thread lock, put a little bit of thread lock. It's kind of hard to see through these openings. It's kind of hard to see if there's any rubbing, but if you look with a magnifying glass and some good light, you can try and do that with a magnifying glass and shine a light. Or you remove the bell and do a close inspection. You look at it from the side and make sure there's not one wire that's sticking out more than the others, as in this one was pretty obvious the way it was sticking out. So you can actually, with your fingernails, you can actually push the wire to the side and down, or you can use any kind of plastic tool or the tip of a propeller. You can use it to mold the wire so that it lowers it. So that's one way to fix it. I wish I had seen it earlier. I would have done that, but I just went ahead and ran it. So actually, I already ran the motor on the thrust test. So I'm doing this tear down after I ran all the thrust tests. So it actually didn't affect any of the performance, but I'm sure eventually it might even cut through it and cause a short or burn the motor for sure. That's one thing to keep in mind with these budget motors. The air gap is actually pretty tight on this motor. It's gonna be kind of hard to see it, but it's pretty tight for being a budget motor. They sure gave it a very tight air gap. So that's gonna help it a lot to perform pretty well actually on the thrust stand. So there's a pretty good resistance to spinning. I don't know if you can hear the how tight the air gap is. That's how you hear the magnets and the stator making that nice noise. Okay, so now that we looked at it, let's go through the thrust test and see how it does, see how it compares with the other motors. So one thing to keep in mind is that these are static thrust tests, so therefore both the amps and thrust are going to be somewhat exaggerated, especially the amps. These look quite high, but don't let that worry you, because it's static, and I'm using a power supply that's able to maintain voltage throughout the test run, and it's also able to supply all this current. So when you're in the air with the battery, the battery is not going to be able to maintain voltage and current to all four motors. So, and also the props unload in the air. When the props are moving, they're going to grab less air, so the load is less. That's what we mean when we say the props unload in the air. But this is typical for thrust tests. The amps and thrust is somewhat exaggerated. So a good calculation to do is you multiply these max numbers from my test results. You multiply them by about 0.75, anywhere from 0.75 to 0.65, and that's going to give you an approximate max thrust, max amps in the air for that particular combo of motor and prop. I found that it gets you pretty close. You can use that to size your ESC, or to make sure you're not run into any dangers of burning your ESCs. Anyway, that's what I've been using, because I used to use a couple of batteries in parallel, two large batteries, 4,000 milliamp batteries, and I would charge them all the way up. So I ended up with 16.2 volts, and that's what all the tests were at. So I just trying to maintain consistency throughout all the tests. So I decided to keep the voltage at that level. Anyway, with that aside, let's look at the results. Alright, let's quickly recap the results for the thrust test on the AOKFLY RV2306-2400KV. The motor tested measured pretty close at 2380, pretty close to the stated KV value, and pretty good results actually. I was pretty surprised to see these pretty good results out of this budget motor, especially considering the one issue I had with one of the windings hitting the top of the bell. But overall, the motor is performing quite well, as you can see on the thrust test results. Even on 5S is approaching 2 kilograms. On the lighter 5-inch props, it's clearing 1400 easily, and as we get onto the heavier props, it's clearing 1500. And then on the 6-inch props, it clears 1700, approaching 1800 grams of thrust. And during the test, I didn't notice the motor to get any hotter than usual either. So it seems to work pretty well. It looks like the tight air gap that they gave this motor it's helping it. But overall, I think it's a pretty decent motor, pretty good. Just keep in mind that it does come with some questions on quality control, as you saw on my one motor. And so it's always good to inspect it before you use it. Make sure you check as I mentioned, check the motor, the shaft retaining screw. Make sure it's on, not tight, because if you tighten it too much, it's gonna bind the bearing. But make sure it's secured with thread lock. If it doesn't have a thread lock, I would really suggest to add a little bit of thread lock on it. And it shouldn't be over tightened then, because also it's gonna bind the bearing, and it's gonna ruin it. It's gonna lead to an early death of the bearing. So you have to just fit it just ever so snugly, And also check that inside is nothing's rubbing, as I had the one issue with the wire. So you're gonna have to try and look through the gaps on the bell, or disassemble it and check if everything's where it should be. So if you're on a tight budget, this one's worth considering. If you can afford a couple of dollars more, I would get another brand that's known to have better quality. But this one could work very well for some people that are on a budget. but it's not overly cheap either. It's like $12. So it's kind of in the middle, not quite budget like the Racer Star, which is like $9 or $8, I think. Based on the performance, is worth considering. As far as durability, I haven't really researched yet to see how it's doing after long-term use. But I'm sure if you scour the YouTube or even the Banggood reviews, you'll get a sense of how the motor's doing. For that, you need to run it for a while and check to see how it survives crashes and how it's performing after running a few batteries through it. So okay, that's the review. So hope you find that data useful, and thanks for watching.